In this video, we're going to talk about a special type of graphic organizer that's really useful with functions. And this graphic organizer is called the rule of 4. And it turns out that with functions, you can represent them contextually, that is, with some verbal description. You can use a table of values. You can also construct a graph and write an equation. And it doesn't matter where you start in the rule of 4. But in this case, they've given us the context. So we are going to start there. And then let's decide, do we jump right to the equation? Do we go to the graph? Or do we start with the table of values? Okay, so the context is about Sammy the squirrel. He started the day with 5 acorns. And then he began looking for more. After 5 minutes, he had found a total of 12 acorns. After 10 minutes, he found a total of 19 acorns. After 15 minutes, he had found 26 acorns, and after 20 minutes, he found 33 acorns. So I think it just makes sense where I see the numbers and I see the table right next to it that we complete this table of values. But let's figure out what is our independent variable and what is our dependent variable. Now, our independent variable, right, is very often time. And in this case, time makes perfect sense because it's time in minutes. And the dependent variable is what we're keeping track of, in this case, the number of acorns. Found after that many minutes. So the 0 is given to us in the table. It's always a really good idea to include 0. So even if none of these values were given, save space for 0. That's really important. That's what we call the initial value, right? It's the starting point. So at 0 minutes into this, he started the day with 5 acorns. Now it says, so this should say number of acorns in total, right? After this many minutes. Okay, so then it says after 5 minutes, he had found a total of 12 acorns. Now, that's the 5 that he started with, right? Plus it looks like some more. After 10 minutes, he had found a total of 19 acorns. Again, the 12 that he had plus some more. After 15 minutes, he found a total of 26 acorns. And after 20 minutes, he had a total of 33 acorns. So it's always a good idea to put an abstract in here. After X minutes, how many acorns will he have? And we may have to wait on that. What I want to do now is take this table and graph this information, because that often helps me find the rate of change, and it also helps me find the equation. So I'm going to double click on this. This is a Google drawing. And I'm going to just paste down that table that I had a minute ago that I had copied. Move it out of the way. And let's see what we have. Time in minutes is down here. And amount of acorns. And the title of this is Sammy's Acorns. Okay, so it looks like my interval is given in minutes of 5, so I can continue this. It looks like every 2 vertical lines will be 5 minutes. You always want your scale and your interval to be in equal increments. And then it seems like I'm jumping up 7 here for the number of acorns. And I've started at 5. I skipped over 2 lines and I'm at 12. Now I'll skip over 2 lines and I'll be at 19 and 26 and 33 and 7 more would be 40. Okay, so what we want to do is we want to place these points to represent the ordered pair 0, 5. This is my initial value, right? It's my y-intercept, it's my starting point. And then I want to go 5 minutes in, he has a total of 12 acorns. 10 minutes in, he has 19 acorns. 15 minutes, 26 acorns. 20 minutes, 33 acorns. Now, I do want to just point something out here. It's not typical that we would count by sevens on the y-axis. The reason why I did that is because I noticed there is a constant rate of change. So this is definitely a linear function. As x increases by 5, y increases by 7. Now, I could have put 5, 10, 15, 20, 25, 30, but that would have made it difficult to place my dots. So that's why I decided to use a scale going from 5 to 40, and my interval is counting by 7 every other line. So this function is absolutely linear, right? Without a doubt. So I'm gonna delete my table and then just save my drawing. And that might help me when it comes to finding an equation. So my equation is always in y equals mx plus b form, right? When we know that it's a linear function, and especially when we know the starting value and we know the rate of change. Okay, so the starting value is absolutely 5, right? That's going to be my y-intercept. And my rate of change, it's not 7. Be careful there, because yes, while the y value is increasing by 7, that's every 5 minutes. So my rate of change is actually a fraction. Up 7 to the right 5, 7/5 x plus 5. And so over here, after x minutes, there'll be the initial 5 plus 7/5 x. And now we can see that we started out with a contextual situation, right? I jumped right to the table of values. Some people would have gone right to the graph. I then take my table of values and make a graph out of it, and then it makes it easier for me to find the equation. So the rule of 4, pretty helpful tool. This time we used it for a linear function, but you can use it for any other type of function.